Hello, we're Pied Paper, a truthful news aggregation website. It is to no one's surprise that fake news is rampant across the internet. Thankfully, there has been increasing interest in thwarting this wave of misinformation with the help of machine learning. Kaggle competitions on fake news detection have displayed impressive ranges of accuracy on test dataset. However, it is without a doubt very difficult to detect fake news on inference and label it as such. Also, this raises a question of thresholds. If the model softmax yields a value that is somewhere in the middle, should we label the news as false or true? That is why we shifted our approach to do something no one has ever done: gamify news. Now, on the surface, our website looks like a normal news aggregation website. It has all the features that you would find there. You can sort by time range, or oldest to newest. You can also sort by categories. All of these features work. And on top of that, based on how we factored in the Postgres dataset with News API, we can also search for news directly based on their titles, which is not a feature that every platform has. However, the important bit, a machine learning PyTorch bit, comes when you actually read one of the articles. Let's say, for now, we choose this article on foxnews.com and pretend that we went through it. I'm not going to go to trouble of reading a Fox News right now. And when we come back, we'll be prompted with this question that we have to answer. When we choose one of the choices, it tells you and compares you with hundreds of other readers who may have read this article, and the machine learning algorithm that weights this on a softmax scale. Now, technically, softmax function isn't supposed to be interpreted this way, but I think it gives you a sense of whether the news article leans one way or the other and compares it directly to people. This inference data is further analyzed in the data section, where we rank the news sources by their average softmax value. Our website revolutionizes how we interact with news in two main ways. Firstly, our website doesn't give you hand-picked information. Rather, you're validating the news yourself. I think this actually strengthens your ability to reason the veracity of news given new information. Secondly, I think we gamify news, and that makes news more interesting and engaging to read because you know that you're going to be challenged at the end of every article.
Our initial model was a convolutional neural network, which ran but had a low accuracy of 50%. In order to improve upon the model, we decided to move to a recurrent neural network architecture, using glove embeddings to increase prediction accuracy. Again, based on an example, an RNN model was built, with the PyTorch NLP library used to speed up preprocessing. This model was more sophisticated, but the highest accuracy we were able to get out of it was again around 50%. So we looked for another model architecture. We found an architecture that used a bidirectional LSTM layer rather than a GRU layer, and no word embeddings. This model yielded a 78% accuracy, and so we decided to use this model as our final model. If we were to continue this project, the goal would be to increase the model's accuracy. Applying some sort of word embedding to the model would most likely improve results. Retention mechanisms are also a potential improvement to the model.
The application portion of this project utilizes the Pern stack, which is PostgreSQL for the database, Express running on Node.js for the backend, and React for the frontend. At the startup, the server begins with an initial cleanup of the database to prevent overflow of storage space, and then it sends out a request to obtain a new set of news articles and categories from a third-party API service called News API. Once retrieved, the results undergo a pre-processing step to filter out non-text-based news, since the free tier of News API does not provide the actual text content of the articles. Then, our own custom web scraper program collects the text of the articles which are fed into the SageMaker API in AWS, so that they may be evaluated on their true or fakeness via our machine learning model. After the SageMaker API returns the metrics, they are stored together with the categories, articles properties, and users' votes in a table within our PostgreSQL database, so that it may be served later when a user requests them through the server's REST API.